Hi, we are back, and is this now Wednesday, April 29th? We are gradually asymptotically approaching the last day of class, which is next Monday. And on Tuesday, we have our review class. And then on Thursday and Friday, we have our final, May 7th and May 8th. And I gave you the dates. So let's look at this example. We're now doing definite integrals. I've put down all the integration rules. Those hold whether you have an indefinite or a definite integral. Those always hold. So I'm given this integral, 100 e to the minus 0.1 dx, and I want to find the value between x equals greater than or equal to 0 and x less than or equal to 10. A is always the smaller number. So here you want to write A equals 0 and B equals 10. Okay, so step one is normal integration, except we use these numbers, but we don't do anything with them both. So we're going to use the exponential. We're going to use the exponential integral rule, number 3, given right there. I have to define my values. A is 100. U is always the power on the exponent, minus 0.1x. F of x is 1 here. It's not a polynomial, so we assume it's a 1. And du dx is going to be minus 0.1. We plug this into rule 3. And we get y equals 100 e to the minus 1x. F of x 1 over du dx minus 0.1. 100 divided by minus 0.1. Notice I draw a line and I preserve the constants of integration right here. As I go along. All right? Now applying the fundamental rule of calculus means just to plug this in here and that in there and subtract the 2. So y is going to be equal to, didn't I put 1,000 down here? Oh yeah, this is minus, this is a minus here. Yeah. This is minus 1,000 e to the minus 0.1x between 0 and 10. All right, so that's carrying one step
because that was negative 0.1.
Yes, so
yep.
This was negative 0.1.
Yeah, you have the negative on the start over there to the left.
I know.
Yeah, that's it, yep.
I know. Okay, but I just brought it on under here. 100 divided by negative 0.1 is negative 1,000. So it says take the function, because now this is the function capital F, 1,000 e to the minus 0.1 and put in 10. The upper number is first. Subtract that from the integral that you got, e to the minus 0.1 times 0. Okay? Notice a minus becomes a plus. So when we do this, we get here minus 1,000. That's going to be e to the 1, correct?
Negative 1.
E to the negative 1. So this becomes minus 1, and this becomes 0. E to the minus 0. I could write that out. Might as well, because it's the first time I'm doing it. E to the minus 1 minus, that's going to be minus plus 1,000 e to the 0. There is no minus 0.
In computer science, we call 1's complement arithmetic. There's a minus 0, but that's neither here nor there.
A minus 0. How can you have a negative nothing?
Well, when you have a sign bit, all the other bits are 0.
I know, yeah. There's nothing worse than machine language. Okay, so anyway.
Sign magnitude, too.
We have here, we're going to have a minus 1,000, carrying it out for you for only once. 0.368 plus 1,000. Anything to the 0 is 1. I don't care what it is. Elephants to the 0 is 1. So our answer becomes, let's see, 632, whatever the units are.
Perhaps elephants.
I'm sorry?
Perhaps elephants.
It could be elephants, tons. Okay, well, elephants would be tons. 200,000 pounds is equal to 1 ton. Could be elephants. Okay, or some of my relatives after quarantine for 3 months, especially an Italian family. As Greg knows, a lot of food.
The poor college students, they have both the freshman 15 and the COVID 15 to worry about at the same time.
Right. That's right. Freshman 15, especially as a result of those ramen noodles. I remember those. But at the time I was actually running. Okay, so let's do a number of other examples. Notice we got a number out of this, not an equation. I have no idea what the functional equation is. I would have to do an indefinite integral. So let's make some space here. And now we are going to do some more examples on the definite integral. And let's take example 2. And I have here the integral between 2 and 4 of x third plus 4 dx. Well, this is a really simple one. Don't forget there's a power 1 here, so I can distribute the dx. So I get 2 to the 4 x third dx plus same thing, 2 and 4, 4 dx. All right, now this is a simple power rule right up there. All right, so this is going to be x3 plus 1 over 3 plus 1, and now you have to have your 2 and 4 here. This is going to be 4x, 2 and 4. Okay, you didn't have to have that before. All right, so what we get here is x to the 4th over 4 between 2 and 4 plus 4x between 2 and 4. And we handle each one separately. So we look at the x to the 4th. We're going to put 4 to the 4th over 4 here. We're going to subtract that from 2 to the 4th. And now we're going to add that to the other one, which is 4x. 4 times 4 minus 4 times 2. Okay, so that's going to be 64 over 4. 4 times, no, 4 to the 3rd is 64. It's going to be 256 over 4. Plus 16 over 4. 16 minus 8. So 256 is going to be 64. 64 minus 4. Plus 8.
Oh, no, minus.
Oh, no, it's minus.
Oh,
Minus. I forgot the minus. 64 minus 4 plus 8 is 60 plus 8. And the answer is 68. And that is your answer. No equation. Just a number. So the definite integral between 2 and 4 of this derivative, because we go from derivatives to functions, is this. Notice I still don't know the function. So I'd have to take the derivative without this and add a c and find the c. Here you don't need a c. And the reason is because the c's cancel. But if I have some time, I'll show you. But just right now, we'll have to take it as gospel. When you do a definite integral, you don't need a c because you already have numbers. Okay, let's do another one. Get a little feel for this. The integration rules stay the same. How many minutes? 4? Oh, for a second. Okay, so example 3. I have the integral. I'm not going to do that one. I'm going to do this one here because I already did that, okay? The integral of the square root of x squared minus 9 plus 2 dx between 3 and 5. In this case, a is 3 and b is 5. Okay, so obviously we have a square root here, so we have to change it like we always do to a exponential. Distribute the dx. And each separate one gets their own constants. Okay. So now we know that the derivative of this is simply 2x. But this is a chain rule, right? So you want to look at this. We'll put this in and we'll call this 1. So let's work on actually this integral here. So if we have a, we're going to let little a equals 1. U, what's inside the binomial. Here we have an n. We don't have an n when we do the exponentials. And f of x is between here and here is 1. And du dx is 2x. What's the matter?
Nothing.
Oh,
just cleaning it up so that it's clear on the video.
well, actually, we can do this if you want.
Yeah.
Okay. So, let's finish up the A part here. Okay, so now we're going to plug in to 2. Here. And we're going to get, for A, we're going to get the integral of 3 and 5. No, we already took the integral. So we're going to A is 1. U is x squared minus 9. And that is at the 1/2 power. And this tells me to add 1. And then do the same thing in the denominator.
Got like a minute.
And f of x is 1. And du dx, f of x should be x, shouldn't it? Something's rotten in Denmark. Oh, there's an x here. Sorry. All right. So this is going to be, f of x is going to be x. Everything else should remain the same, except the x goes over here. And this becomes 2x dx. Distribute the dx. So now we have, when we take this part here, a, little a equals 1, u is that, and now f of x equals x, and du equals 2x. Okay, we'll come back next 15 minutes.